Good day and welcome to your Chemistry Help Center. So today we're going to start Unit 1. The next few chapters are going to be about gases. So for the whole term 1, pretty well, we're going to be talking about gases. So let's start with why do we need to know about gases? I mean, besides the fact that the government says so, why is it so important to know about gases? Well, if you think about it for a second, gases are surrounding us. For example, we need oxygen to breathe. If air wasn't surrounding us, well, first of all, we couldn't breathe, but also, as you can well imagine, there would be no pressure, so we'd all look like blips, for example. So it's kind of keeping our body in check, in shape. If somebody goes under surgery, doctors need to be able to calibrate how much anesthetics they're going to give to a person based on their weight and their height. So they, again, need to know about gases in relation to the human body. When we fly in a plane, we need to know about pressurization of a cabin, or we need to understand about air masses so the actual plane can fly properly and not just dive down and crash. So let's look under that little box and see what else there is and why do we need to know about gases. So simply put, they surround us and we encounter them every day. So we need them to live, as I was saying, when we breathe. We need them to cook through combustion sometimes, and we use them at work, possibly, and also through our hobbies. For example, if you go on vacation and you go not scuba diving, but diving with an air tank, well, that's a type of hobby, obviously. You'll need to breathe some kind of air or some kind of gas mixture. We need to know about gases to explain certain phenomena and develop new technologies based on our knowledge of gases, their properties, and their behavior. So again, when we talk about airplanes, that would be a good example here. Next, what are important gases that we know about? If we look about what air is made of, you know from last year that about 78% is made of nitrogen, 21% is made of oxygen, and the rest is a mixture of gases. So you have argon, you have carbon dioxide, and you have other gases, methane and whatnot. Now, if we look about the most prominent ones, nitrogen and oxygen, we have, for example, nitrogen, which is the most abundant gas. It plays a role in the nitrogen cycle. So that would be one important point about nitrogen, why we need to know about it, because we need to understand in order to not disrupt that very important nitrogen cycle, which we talked about last year. Don't worry, you won't have to relearn all these processes. It's just to kind of explain this point to you. Next, we have oxygen. So we know that we need oxygen to live, right? Plants do, and we do too. So we have, for example, oops, sorry about that. Let's just zoom a little back. Oh, that doesn't work. Oh well. Here you have photosynthesis. I'll move it here, whatever. You don't need to know it by heart, by the way. It's just to illustrate the idea once again. So photosynthesis for plants, they need oxygen. Actually, when they do photosynthesis to produce their food, which is sugar, they produce oxygen at the same time. So they purify the air that we breathe. Now, at night, so that's during the day, at night, they use that sugar, and along with oxygen, they produce the energy that they need to live. They give off carbon dioxide at the same time. Okay, so during the day, they use energy to do photosynthesis. At night, they breathe, basically, or they use that sugar, that food that they create during the day. Okay, another important gas, methane. Methane comes from the fermentation of organic matter. Could be in marshlands, could be in landfills, could be bodies as well. When you fart methane, amongst other gases. Okay. We also talk about cows. Cows produce a lot of methane, again through flatulence. So that's why here it says it's produced during digestion. Radon, another gas. This one is a little bit more rare, but still important because we can find it in our basements. It is not dangerous in very small concentrations, but if it were to be in very high concentration, which is extremely rare, so you don't have to worry about that, it can cause lung cancer. Okay, so it's just a few examples of gases that we encounter, like I said, every day, and that it's important to understand what they do or not do for us, so we can either protect ourselves or use them intelligently and maybe create technology that will make our lives better. Okay, next. Name properties of gases that you know. We learned in the past years that, let's see, oops, sorry about that. Let's see what's under this box. For example, some of them are reactive. If you think about chlorine, because it's a halogen, it's only missing one valence electron. Well, it's really quick to react and to attain stability, so it makes it extremely reactive. Nitrogen, it's compressible. We're going to often find nitrogen tanks. That nitrogen is very cold, so it can be used for cryogenics, to freeze human tissues, for example, to conserve them for a while. We know about diffusion. So gases will go from an area of very high concentration to an area of very low concentration. You know also that gases ionize. If you think about your quantum theory from last year, if you give energy to a gas, some of its electrons will become very excited, will leave, but when they come back, because they don't like that state of high energy, when they come back, they'll release that energy in the form of light, which we see, depending on the wavelength, depending on the amount of energy that's released, we'll perceive a certain color. We know that they're very light, and we know that oxygen, for example, allows for combustion. Now, name phenomena explained by the knowledge of gases, properties and behavior. Let's see. We have combustion, been talking about it. Aurora borealis, so the northern lights, you see that obviously up north. So that's also, again, based on the quantum theory. That's a very good example of it. Volcanoes, weather patterns. We talked about air masses last year. So another phenomena based on temperature of different air masses. They'll move differently and create different weather patterns. Respiration, photosynthesis, I'm not going to repeat. Carbon, nitrogen, and phosphorus cycles, again, I will not talk about. We've talked about that enough last year. Name technologies that were developed based on the knowledge of gases. I've named a few in the past few minutes. Planes, for example. We have also aerosols. So when you spray something with a can, it uses compressed air. Refrigerators, it uses a gas that will capture all the heat and therefore cool air that is, let's say, circulating through an AC unit or through a refrigerator, so to keep the food cool or to cool off air that is released by the AC unit. Airbags. Airbags creates nitrogen, so we need, again, to understand gases. This is a perfect example. If we understand how much nitrogen or how the reaction works, we can predict how much nitrogen will be released by a certain reaction, and therefore how big the airbag must be in order to blow enough that it will protect you, but that it's not too small either that it's going to blow up in your face if there's too much gas being produced. And if we understand at what rate that gas is being produced, we can also figure out, during an accident, that airbag has to be deployed fast enough to, again, protect you. Not too slow, not too fast. So we need to know how these reaction works and how much gas is being produced and how gases will move around in a certain size container in order to create that great item, which is an airbag. Anesthetics I talked about. Tires. In the winter, when air is cold, the pressure inside the tires will be lower. In the summer, pressure will be higher. So you won't necessarily have the same amount of air. You don't want to put the same pressure in your tires based on temperature, because you want to get the perfect ride. You don't want it to be too hard. You don't want your tires to be too mush either. So again, by knowing how gases work, what their properties are, we can decide how much pressure to put in the tires to have the perfect ride and not use too much gas either. So it's not only a question of comfort, but it's also a question of efficiency as far as combustion goes. Next, other technological uses of gases. By the way, in page 42 of your textbook, you'll have a whole list there. You don't need to know them necessarily by heart. This is more common knowledge or just extra knowledge for you if you're interested. Here are important ones or common ones. So nitrogen can be used as a food preservative. Rather than putting air, bacteria need oxygen in order to oxidize the food and basically make it go to waste. So by putting nitrogen instead of normal regular air, you're slowing down that process. Nitrogen can be used as a fertilizer. In tires as well, it's not as, When it's cold and hot, the pressure will not change as much with nitrogen as it will with normal, regular air. And cryogenics, as I was saying before, nitrogen in the liquid form is much colder, and therefore we can use it to freeze certain tissues in order to preserve them for a later use. Compressed air can be used for tools, nail guns, for example, in construction. Scuba diving, oxygen, pressurization of planes inside of them, I should say. Surgery, so you have to breathe, right, even if you're under. And ignition for the fireplace, or for combustion. Combustible gases. We use them for cooking, for barbecue, for example, barbecues like methane or propane. Cooktops as well if you're using a gas stove. For heating, again, if you're using gas rather than electricity. And for transportation, all cars pretty well use combustion. Well, not pretty well, they all use combustion in order to propel themselves. So again, it's a good example of combustion. So again, if you want to see other applications of compressed gases, else than just a nail gun, you can go to page 43 of your textbook and read that. And on page 49, you'll find a history of anesthesia if you are interested. Again, these pages are not mandatory, it's just for your own personal knowledge. Okay, lastly, one little fun fact. Well, I don't know if it'll be fun for you, but it's a fact certainly. Have you ever wondered how fish float or how they go up and down? Well, actually, they have what we call a swim bladder. It's also called a fish bladder. So that's not really a bladder that collects urine. It actually collects air, the air that the fish gets from the water. So it will either fill this up and therefore change its buoyancy, make the fish lighter. The fish will go up, let's say in an aquarium or in the ocean or a lake. And when it wants to go down, it will get rid of the gas inside the swim bladder, so the fish itself becomes heavier and can swim down to a greater depth. So there you go for your fun fact, or your fact anyways. So that's it for lesson 1.1. Stay tuned for your next episode. Bye!